Hi everyone, in this video we are going to take a look at using cylindrical coordinates to compute the volume of the following solid. So it's a paraboloid, so that would be z equals x squared plus y squared, and on the top it's bounded by z equals 11. Okay, so try to figure out what is the projection of the solid onto the xy plane, because in order to integrate this right here would be that projection. So let's just call it r, and then this should be bottom surface to top surface. So it's pretty easy to see from the picture that the bottom surface is going to be the paraboloid and the top surface is going to be z equals 11. But what is going to be the projection? So if you think about it, the projection means that you're basically taking every point on the solid and making the z coordinate of that point 0, but keeping the same x and y. So what will happen is you will definitely get a circle here, right? This is going to be the circle on the bottom. That's going to be the projection onto the xy plane. Here we won't see it. Okay, so what is the radius of the circle? How do we figure that out? Well, the radius is going to be the intersection of the paraboloid and the plane z equals 11, right? So in order to figure out where they intersect, you just have to make them equal each other, which means that x squared plus y squared is going to be 11. And this, hopefully, you recognize as equation of a circle. What is the radius, though? So 11 is going to be squared radius. So the radius of the circle is really square root of 11. Now, to show you what exactly the solid is going to look like, let's see if we can practice that in Calcplot 3D. So I am going to get rid of this and let me add a region. Okay, so this region is going to be, I want to draw the circle, this x squared plus y squared equals 11. That's going to be my 2D region. Now, in order to do that, I have to have the top curve and bottom curve. So when you solve this equation for y, this will become y squared equals 11 minus x squared. But then if you want to solve it for y itself, that's going to be plus minus square root of 11 minus x squared. The positive square root will be the top part of the circle, and the negative square root will be the bottom. So let me show you what that looks like. So it will be square root of 11 minus x squared. That's going to be the top. Bottom will be square root of 11 minus x squared with a negative, okay? Now, you can't really see this because, first of all, x should start at negative square root of 11 to positive square root of 11. That's the bottom surface is that, but the top is 11. Okay, so now to see this, so that you can actually see this, we're going to have to zoom out. And so you can see the projection right over here, that circle of radius square root of 11. But now you can also see the solid, right? So it's on the bottom bounded by the paraboloid, and on the top bounded by that z equals 11. And then this is the projection. Okay, so hopefully now you understand what's going on. So let's see if we can set this up. So again, just like before with cylindrical coordinates, if you want to find the volume, you just integrate in one, but you have to insert that extra r, which is called the Jacobian, and then this is dz, dr, d theta. Now, let's see if we can set it up. So first we're integrating over the circle, so this is going to be 0 to 2 pi, and the radius of the circle is square root of 11, so that's going to go from 0 to square root of 11. And then the bottom to top, so I've already showed you that the bottom is going to be that paraboloid x squared plus y squared, right? So that's going to be the bottom, so we'll put that here. And the top is going to be that z equals 11, right? The flat, the yellow, you can see the yellow plane. Okay, so that will go to 11. And we are basically done setting it up, except this right here is actually r squared. Because remember, we are switching to cylindrical coordinates, so you can't have x and y mixed up with r and theta. So, but remember that x squared plus y squared equals r squared. Okay, so let's just integrate. Now, we can't split this yet. So remember my favorite technique of evaluating triple integrals, if it's possible to split them, I do that. But I can't because one of the limits right now is r squared, and that has a variable in it. So I can't split. But I think once I integrate one time, I will be able to split the remaining double integral. Okay, so let's see. So I'm just going to rewrite it so that it's more clear what we get. So r dz dr d theta. So first let's integrate the inside and leave the outside alone. Okay, so this is r with respect to z. So that will be r multiplied by z, because remember r we think is just a number. So integrating a number, which will be the number times the variable with respect to which you're integrating. And then we substitute z equals r squared, and then z equals 11. Okay, and still leaving dr d theta there. Okay, so 0 to 2 pi, 0 to square root of 11. And here I have r. Okay, so let's substitute. First we substitute 11 and then minus r squared. And then we have dr d theta. Now we are ready to split it because this integral does not have anything in the no variables in the limits. And also it doesn't have a theta. So we can certainly split it as 0 to 2 pi d theta. And then 0 to square root of 11, I'll integrate the r integral, but we do have to distribute this r. Very important, this r belongs to both terms. So this will be 11r minus r cubed, right? Okay, so that becomes 2 pi. And then here 11r squared over 2 minus r to the 4 over 4. And we substitute 0 square root of 11. Okay, so just to pretty it up, let's substitute square root of 11 for r. When you square square root, that just goes away. So this will be 11 times 11. So I think that would be 121. Now this one is the same as r squared squared. So this would be 11, right? When you square it and then square it again, that's also going to be 121 divided by 4. Okay, so it's pretty easy to simplify that. You can check that that's just 121 over 4, because this is like 2/4 minus 1/4, which is 1/4. So my final answer is 121 divided by 2 pi.